Welcome again to our YouTube channel. Today I'm going to show you about the differential calculus. First of all, in differential calculus, we have a function. And a function is a rule that assigns one input to exactly one output. A function is just a rule that assigns one input to output. Let me show by an example. I.e., if I have 1, 2, and 3 as my own set, therefore this one, because we are saying a function is a rule, this is going to appear in this form. Like here, let it be appear to 1, 4, and 9. This one is being assigned to this. 1 is being assigned to 1. 2 is being assigned to 4. Then 3 is being assigned to 9. Meaning there is a function that this assigned to this. That function, let me call it x. That function, x is a function which is square. If I take 1 square, I will get 1. If I take 2 square, I will get 4. Then 3 square, I will get 9. Meaning our function here is square. And this input, this is the same as input. Then this is our output. And this input is what we call the domain. And output is called the range. The domain is usually B independent. But the range is dependent. For example, e.g., if I have an equation like y equal to x plus 2, the value of y is my range, which is depend on the value of x. For example, if x increases, automatically the value of y increases. But not necessarily the value of y increases our x, it will increase. No, but this one is our dependent. And the value of x is independent. The value of the y depends on the value of x, meaning this one is our range. And the value of x, it will be our domain. Now, let's go and look at the domain of the function. The domain of the function. Now, we know the domain is the input and is independent. So, the domain, the function define an equation. The function define an equation. The domain is assumed to be the set of all real numbers. It's being assumed to be the set of the real numbers. Then, let's go direct to examples. Now, before example, we have here a note. All the polynomials the domain are the set of number are the domain are the set of real numbers. If you have any polynomial and you have been told to find the domain it will be all set of real numbers in that function. Let's go to our first example. Our first example is find the domain. And our equation is the f of x equal to 3 all over x squared minus 25. And we know the domain is the set of inputs, which is independent. In this case, our domain is here. This is our domain. And you know 3 over x squared minus 25, we have, this is our domain, and we have to find the value of x. It will be this way. Solution. X squared minus 25 must not equal to 0. That one we have to know. Since if our x squared minus 25 to be 0, all our equation it will be infinite. Therefore, we have to, this value must not equal to 0. Must be any other number but not to 0. If that way, then I'm going to solve and remain with the value of x. Therefore, negative 25 will cross the other side. It will be x squared equal to, not equal to 25. This is the same as x not equal to the root of 25. Meaning x is not equal to positive 5 and x is not equal to negative 5. In this case, this is our solution, but we have to make a conclusion this way. The domain of x squared, not x squared, of the function f of x equal to 3 all over x squared minus 25 is the set of all real numbers except when x equal to positive 5 and x equal to negative 5. It's all the set of real numbers except when x equal to 5 and negative 5. This is our first example. If you have been told to find the domain of the function, it's very simple. For the second example, example number 2, y equal to the root of 2x plus 6. Let's go to solution. You have been told to find the domain of this equation. Then, the root, this is our range and this is the domain. The root of 2x plus 6 is our domain. So, we want to find the value of x. Remember, the root of 2x plus 6 must be 2x plus 6 must be greater than 0. Since the value of this domain, we don't have the root of 0. Therefore, it must be greater than 0. Then I will take positive 6 on the other side. It will be 2x equal to is greater than negative 6. Then I will divide everything by 2. I divide by 2. X must be greater than negative 3. If we put here, we substitute the value of x here, it will be negative 6. And negative 6 plus 6, it will be 0. Meaning, the domain of y equal to the root of 2x plus 6 is the set of all real numbers except when x equal to negative 3. Then our third example should be y equal to x cubed plus 2x squared plus x plus 1. Then the fourth one, y equal to the cube root of x 2x plus 8. These two examples, the answer is the domain is the set of all real numbers. Even this one, the set of polynomials. It's a set of, this one is a polynomial, meaning the domain is the set of all real numbers. Then this one is an ordered, I think. All ordered numbers are the domain. The domain are the set of all real numbers. Our fourth example, the domain is the set of all real numbers. Thank you guys for watching. Let's meet on another video. Thank you.